Right. It is 9 o'clock. I'm going to get started. The homework assignment is due on Wednesday, just to make sure that you guys know it's not due 21 seconds ago. All right, so are there any questions about the... Yep, go ahead.
Is about the homework?
Hmm?
So the questions for homework?
Yeah.
Okay. So I've done it and it works, but I just want to make sure. So it's the second part is supposed to recover it. So is that like the previous time it recovers the characters? So if I type in like ABC and then 32 over 8, it should just return one horrible one.
So let me address that one as soon as the whole class is ready.
Okay.
So I think they are ready. All right, so for the inputting part of the homework assignment, what you need to do is to make sure that it reads the whole fraction as one thing, okay? So you want your format string to be like this. So you want the format string to be %u, which is an unsigned integer, slash %u, which is another unsigned integer. So this should be the format string of your scanf, so that you can read in the entire fraction as a whole. So that also means if you have an integer followed by some gibberish followed by slash, it's not going to recognize it. Okay. This will accept something like 34 divided by 56. It will take it in. If you have 34 ABC slash 56, that's not going to be. It cannot be accepted as an input because it's not in the format of a fraction. Okay. And because the way we are changing the format string, instead of looking for one thing, we're now looking for two, the range of the return value of scanf will also change a little bit from the homework assignment that you did before. Okay? So you kind of have to think about that before you reuse any code from the previous homework assignment. Depending on how you structure your code in the previous homework assignment, you might need to change the control structure because of that one extra value the scanf can be returning. You had a question?
So if we get something like that, then the program should return this fraction is invalid?
Okay, so what happens here is it will read in the 34. Okay, the scanf will read in the 34. It will return a 1 because it can only get one thing out of the two that you asked for. And then at this point, it will be ready to read the A, but it won't be able to interpret the A as a part of a fraction. So you have to get rid of the A, get rid of the B, get rid of the C, and the slash all on its own is also not going to be useful because it's always looking for an unsigned integer followed by a slash, followed by another slash, followed by another unsigned integer. So that one is no good, no good, no good. And when it gets to 56, it will see it as one single unsigned integer, which means scanf once again will return a 1, and that's not good enough. So in other words, if this is the actual input, you should not recognize it at all. Okay, this should all be ignored, and hopefully after this we have something that looks like an actual fraction. On the other hand, if this 56 is actually followed by 72, then it should be okay.
So I don't have to worry about trying to figure out how to get the bottom one accepted.
Which one?
So I only need to worry about getting 34 and 56 accepted. Right?
Well, okay, this part it should ignore, and then this part it should accept. So this will give you a fraction of 56 over 72, but the earlier part, they all have to be ignored because scanf won't be able to read any portion of the. Okay, let me just highlight which portion. So the scanf using the format string as it is this one here cannot recognize the highlighted portion because it does not fit the description. Is that okay? All right. Are there any questions? Yep.
Just like you did the last homework assignment, can you give us some test cases and what they should look like?
Yes, I can. Yep. So I can give you a few test cases here. Now, in the input of this one, I will always give you something to process because the main function itself is always going to call, simplify, and then print it out. So that means if I give you something that cannot be processed, the program will be broken, but not because of your code, but because of the main function which I wrote. Okay, so I'll give you something here. Okay, so let's just take this one here. If this is the input, the output would be the simplified version of 56 divided by 72, and in this case, 76 is 8 times 7, right? So 8 times 7, so 7 divided by 12 is the output. Okay, so if this is the input being this, then the output should be that. Is that making any sense? Well, okay, I take it back. I cannot do my division. That's 9. 7 times 9, 8 times 9 is 72. I can't do my math without a calculator, that is. Any questions about the first test case? Okay, I'll give you a few test cases, some are pretty simple. Okay, the second input would look like this. So let's say we have 0 divided by 1, okay? So this one is really easy. The output should just be 0 divided by 1. Now that means you have to test, when you're doing the factoring, you have to actually test for 0 and 1. The factoring program itself does not, okay? In the factoring program, I guarantee that the input would be at least 2. But with this one, it can be less than 2. So for 0 and 1, there's nothing to do. That you cannot factor 0 nor 1. Okay. So a simple conditional statement can take care of that one. I'll give you another one. So let's say the input is, okay, this one is a little bit trickier. Okay, 34 / 72 slash, I don't know, 10. Okay. So with this one, the attempt to read in an unsigned integer, a single slash and then another signed integer will fail, okay? Because this slash here is not supposed to be there. So it will give you 34, it will recognize the first slash, and then will stop and say, hey, I can't read any further, okay? Because whatever follows the first slash is not an unsigned number. So at that point, your program will have to say, okay, we'll clear away this junk here, whatever it is. And then once you clear away this junk, you will attempt to read or scanf again using the format string that we mentioned earlier. So let me see if I can still see that. Using this particular format string, in which case it will see the 72, a single slash, and a 10, and so that will be recognized as a unsigned, a slash, and an unsigned. So it will take this number in as the actual input, and as a result, the output is the simplified version of that. The common factor is 5, it is 2, so the numerator is going to be 36, the denominator should be 5. All right, are there any questions about these 3 test cases? Okay. Do you guys want to mention any test cases? Like, what about this one? Yep.
So I entered a negative number and
You cannot put in negative numbers. It will fail.
Okay.
So, okay, let me give you one test case here. Okay, so let's say you have a negative symbol to begin with, okay? So if you put in, say, negative 300 divided by 100, okay? The output should be 3/1. Because it will scan the negative symbol first, and it will come back and fail and say, hey, this is not even the beginning of an unsigned number, so it will fail on the negative number, then you have to get rid of it. But once you get rid of the negative symbol, then you have 3/100, which does fit the format that you're asking for. So now you will read in 300 as the numerator, 100 as the denominator. Once you simplify it, then you get 3/1. Okay. Now what about the next one? Okay, let's take a look at the next one here. The input is 30 divided by -10, comma, -10 divided by 30, okay? So with this one, the output would be 1/3. Because the output, let me just move this up a little bit because people in the back may have problem looking at this portion. So move up and resize. There we go. Okay, so with the last test case, 30 is okay, the slash is okay, and then it sees the negative symbol, which is not okay for an unsigned number. So it will fail. It will tell you, well, of the 2 things that you asked me to read, I was able to give you 1. And then it gets stuck with the negative symbol. Then you get rid of the negative symbol. You see the 10, and then the scanf will return 1 again because of the two things that you ask it to read. It was able to read the 10, but the comma is not a slash, which is what it is expecting. Then it will fail again. Then you will have to get rid of the comma. Then you will see the negative symbol. The negative symbol, the second negative symbol in this case, is going to fail because you're asking for an unsigned number to begin with. Okay, so that will fail. Your program should clear that negative symbol. Then we'll move on to the 10. 10 is good, slash is good, 30 is good as well. So it will read in the 10 as the numerator, the 30 as the denominator, and you simplify that, it becomes 1/3. Are we doing okay so far with these test cases? Okay, do you guys have anything else in mind?
What if we get like A over B?
Huh?
What if we get like A over B?
Then it is not a number. Your program will basically, if the entire file, okay, if I give you, A over B like this, then it will not recognize it as a fraction at all. And then if this is actually coming from a file, and then it will see end of file. Now, when you see end of file, your program, your code has to exit because there's nothing you can do about end of file. So what will happen is it's going to return an uninitialized fraction to main, and then main will try to do a simplification on an uninitialized number, which is not going to work. So I cannot give you an input like this. It's not going to work. But I can give you something like this, and it should work. That will work. Because it will see the A first, which it will fail, and say, hey, that's not what you asked me to read. It will return, in fact, a 0, because of the two things that you're asking to read, it does not even match the first one. Okay? Then you have to clear away the lowercase a, then it will see the 8, the slash, and the 3, and that fits the format that you are asking it to read. Then it will go ahead and return a value of 2. Scanf returns 2. That means you have just read what you need, and the output of this one is just 8/3 because you cannot factor this any further. So in your output, I don't want it to be any. I don't want any fancy stuff. Okay, I don't want you to say, oh, the simplified fraction is, or anything like that. Just give me an unsigned number, a slash, another unsigned number. Because otherwise, the grading script will not recognize it because it just wants the simplified fraction. It does not want any extra text whatsoever. Are we still doing okay so far with the sample input and the expected output of this program? Now, if you have any questions about what is going to be returned, what you really should do is to write a simple program, just a simple scanf with %u/%u as the format string, and just give it something, and then check the return value and see what it is actually returning. Okay. Are there any questions about that part, about writing a short, simple program and just test it with a single test case each and every single time, just to check out and confirm the behavior of scanf? No questions? Yep, go ahead.
So you use %u. Can we use %b?
No.
No, that's b.
You have to use %u because of the type of the numerator and the denominator. Right. Any other questions? If there are no questions, we're gonna move on. Okay, so we still have the lab time today, so it's not like we cannot talk about this any further. If you have any questions that you want to show me, like, I wrote this program, this is the behavior, what is wrong with my program, we can do it during the lab time, okay? But during the lecture, we're going to move on to the next concept that we'll be talking about. I rearranged the topic a little bit again. I put arrays ahead of the other stuff, which is program development and modular programming and using top-down design. Program development is not unimportant, but I think it's kind of a softer skill instead of a hard skill. It's not C++ specific, and as a result, we can talk about this later as a review instead of putting it right in the middle of a semester. So I would much rather take care of all the technical stuff first, and then we move on to the kind of softer stuff. All right, so we're going to move on to arrays. And the first question I have to the entire class is, do you know what is an array conceptually? In other words, when you took CISP 300 or 301, or whichever class that you use to fulfill the prerequisite of this class, did they talk about arrays? Okay. And so if so, can someone tell me what is an array? I mean, just general description. What is it, and how do we use it? Nobody wants to volunteer? Go ahead.
Groups of information.
Okay. So it's a way to create a collection of things, right? You know, multiple things get combined into one. But isn't that structure? You know, structures can do kind of the same thing. You can put multiple members into one structure, and that one single structure now has multiple components, and each one can be accessed individually, or can refer to the entire structure. How is an array different from a structure?
Can only have one type, or one integer or char type.
All right, excellent. Okay, that answer is great. Okay, the answer was with an array, everything inside an array must have exactly the same type. Whereas in a structure, hey, you can do whatever you want, okay? So a structure can have one member being an integer, another member being a pointer, and yet another member being another structure, okay? They don't have to have the same type. Whereas in an array, all elements in an array must have the same type. So that's one thing that is really important about arrays. What about another important concept of an array? How do we use an array? Using indices, okay. And as opposed to in a structure, how do we specify individual components or members of a structure? It's by their name, okay? You know, so you have D being a date, so D dot month refers to the month member, D dot year refers to the year member, and in your fraction homework assignment, you have numerator as a member, you have denominator being a member, and use the dot notation to say, oh, I don't need the entire structure, I just need this member of the entire structure. But in array indexing, you use a number, you use an integer. In fact, you use a natural number because it starts with 0 to access individual members of an array. All right, so those two are very, very important concepts of an array. So we'll just go ahead and kind of remind you, what is an array. All right, so conceptually, an array has the following attributes. Some of these are universal, and some of these are specific to C and C++. When you refer to an array, you can see the entire array as one thing, okay, instead of individual members. An array may contain 0 or more elements. Now, I cannot imagine why anyone would want to have an array with 0 elements, but it can be done, okay? Just because it doesn't make any sense doesn't mean it cannot be done. It can be done. So I'll just say that it can have 0 or more elements. Each element within an array is identified by its index. Now the index, quote-unquote index, is simply a number. It's a natural number, which means it goes from 0, and it's a whole number, 1, 2, 3, and so on. In C and C++, an index has to be a non-negative integer. In some other programming languages, you can specify an array to start with some negative integers as the first index, but in C and C++, you must start with 0, which is the next point. Okay, so in C++, C and C++, and many other programming languages, the first element has an index of 0, and you cannot change that. Okay. Indexes of elements must be consecutive, so you cannot skip. You cannot have an array where you have elements of at 0, 1, and then 3, and then 10, and then 20, and then 25, and so on. They must be consecutive numbers, 0, 1, 2, 3, 4, 5, all the way up to the maximum number, the number of elements minus 1, because the last one has that particular index, which will be discussed later. all elements of an array must have the same type. Now that type doesn't have to be simple, okay? You can have an array of integers, simple type. You can have an array of structures. You can even have an array of arrays. That's perfectly okay as well. There's nothing that says you cannot have an array of arrays. An element in an array is specified by the array itself, followed by the index and the indexing operator. In other words, you have to specify which array and then another operator to specify which element of that array. The indexing operator is a pair of square brackets in C and C++. I believe in some other programming languages, including Visual Basic, Lisp, and Lisp, they use parentheses instead for the indexing operator. Did someone take cisp360 to fulfill the prerequisite of this class? Okay, so in that case, did they use parentheses for indexing?
Yeah, I think so.
Yeah, I think that is the case because I always type square brackets when I do Visual Basic programming, and then VB will come back and scream at me and go like, I do not recognize this. But then I don't recognize it either as a proper programming language. So we're even. All right, so why do we have to deal with arrays? Well, because it's in the curriculum of this class, right? So I have to go over it. But without arrays, what would programming be like without arrays? Let's just think about it for a moment, okay? And I would illustrate it using a program that we already know. Okay? Just going to use mousepad here. It's easy to type here. Okay. So to find the maximum of two variables and store that into Z or max, it's easy, right? If x is greater than y, and we'll just go back and say, if x is the greater one, then max is x. If y is the maximum, then max is y. Semicolon, there we go. How many people still kind of recognize this code? We did it in the ternary operator way, okay, with that particular homework assignment, but it's basically the same code here, okay, same type of logic. What if you have three variables, okay, which is phi max 3? Well, it's a little bit more complex, but the logic is not any different, okay? So if I have wxy, okay, and I want to store the maximum into the variable max, then it looks like this, okay? If w is greater than, say, x here, there are several ways to do this. I'm just doing it in one particular way. Okay, if I get into this code here, that means w is confirmed to be greater than x, which means x cannot be the maximum. So what is left here is just w and y. So I can now say if w is greater than y, then we'll have this code here. Otherwise, we'll have this code here. Oops. I thought I was using VI, and that's why you see the KK, because K is a cursor up in VI. Sometimes I get cross-wired when I'm using a different editor. Okay, so if W is greater than X and it is greater than Y, then there's no doubt that W should be the maximum. On the other hand, if W is greater than X and it is not greater than Y, then it is also safe to assume that Y is the maximum. Now, in this particular case, W and Y can be the same because I never confirmed that Y is greater than W. They can be the same. Does it really matter? Doesn't matter, okay? As long as Y is greater than or equal to W, Y can still be considered the maximum of the two. Okay, so I can work out the same way as the other one. Now, I just want to do this because I want to illustrate, even though it can be done, okay, but the complexity of dealing with three variables compared to two is a little bit more complex, okay? It can be done. So in the else case here, it means W is less than or equal to X. So I can basically say, okay, let's just consider X being the greater one. So we'll be considering between X and Y. So if X is greater than Y, then we know that X is the maximum. Otherwise, we know Y is the maximum. So we say max is X in this case, and then we say max is Y in this case, and it's all done. Okay, so let me just give you a view of the entire code here. Just a little bit more who's scrolling? There we go. Okay, so this is one way to find the maximum given 3 variables. Not the only way, just one of the methods to do it. What if I give you 5 variables? What if your next homework assignment is to find a maximum of 10 variables? Well, first of all, do you know how to get it done? Yep, it's just very tedious, okay? But it can be done. But 5 or 10 is nothing compared to, let's say, 30,000. But we have about 30,000 students at ARC. I want to find out who has the highest GPA. Okay, so I have to find the maximum out of 30,000 numbers. Without the concept of an array, that becomes kind of a nightmare, right? So, okay, fine. Okay, if without arrays, it makes it kind of difficult to express, certain types of algorithm. So, does it really help with the concept of an array? So, what I'll do next is I'll give you the code to find the maximum of an array of any number of integers. Okay, so give me any number of integers or real numbers or whatnot, and this algorithm will be able to find out the maximum. Okay, so I'll give you the code first, and then we'll explain the code. So I'll start with I'll start with this one, and then I say I gets initialized to 1 while I is less than n. We do the following. Let me say if a bracket I is greater than max, we do something here, and then I gets I plus 1, I plus plus I, they all do the same thing. So the key is this part here. Okay, there we go. So I'm claiming that if you give me 30,000 numbers, I will be assuming that A is an array of 30,000 numbers. Okay, real numbers in the case of GPA, or integers in the case of something else. I'm assuming array elements can be compared. Okay, so we can establish which one is the larger one. But this is going to be the same. Okay, if you give me 300,000 numbers, it will still be the same algorithm. It will take longer to execute. Okay, but we'll still have the same, how many lines? 8, 10 lines. Okay, 8 to 9 lines of code. Okay, but isn't that kind of cool compared to the previous way? Because this way, we have one single algorithm. Without changing the algorithm itself, it can handle an array of any number of elements. Now, obviously, if you give me more elements, it will take longer to execute, but it does not change the algorithm itself. That is the reason why we have arrays. It allows certain types of algorithms to be expressed in a much more elegant and much more concise way. Do we have any questions here? Okay. Now, given that you already have exposure to the concept of an array, we're just talking about syntax here. So let's go over this code here and find out what is the syntax doing here and what is each one doing in this code. We'll start with the first line. Okay. If you look at the first line, it's an assignment operation. Okay. It's an assignment statement which is coming from an assignment operator. Okay, because it's an expression statement in this case. The left-hand side is simple. The left-hand side is just a variable called max. Okay. The right-hand side is, well, we haven't seen this before, at least not in this class. Okay. This is the indexing operator. The square bracket is called the indexing operator. So if A is an array of any number of elements, this is just saying, oh, we want the first one. Okay, give me the value of the first element of array A. And we'll store it into max. So the idea behind this one is I will assume the first element of the entire array to be the maximum unless I'm proven wrong. So if I have only seen one element, I'm just going to say, hey, let's assume that one is the maximum. And then prove me wrong as we scan the rest of the array. That's the general approach. I equals 1 is the next line. Okay, this one I don't need to explain what it is, but I can explain why we need a statement like this. I is being used as the moving index in this algorithm. In other words, I is the variable that kind of determines which element we are looking at for each iteration of the while loop. And we're going to start with 1. There's nothing wrong with starting with 0. Okay, you can start with 0 if you want. It's just redundant because I just put a bracket 0 into max. So if you look into the code, the conditional statement, if a bracket I is greater than max, hey, if max is the same as a bracket I, it cannot be greater than itself. So if I initialize I to 0, I'll just be wasting one iteration of the loop. It is not wrong, it's just a waste of time. Then that's why I move it up to the next one and say, let's start with the second element in the loop, because I have already assumed the first element to be the maximum. And then the next thing we want to pay attention to is this part here, combined with this. Okay, so when you look at the condition of the loop, which is as long as I is less than n, and what we do to I for each iteration, which is the post operation, together it simply means we're going to add 1 to I for each iteration until I is at least the same as n. That's all it's saying. Which is basically saying I'm going to look at elements in the array sequentially from 1 all the way up to n minus 1, because by the time it gets to n, I'm getting out of the loop. But what am I exactly doing for each value of I? That is determined by this code here, the conditional statement. The conditional statement is basically saying, okay, given a bracket I, and remember I is a changing variable, so given I is a particular value, we look at the element I in array A, and we compare that to the maximum value that we have seen up to this point. If a bracket I, which is something that I have not seen before, this is the first time I see it, is greater than the maximum that I have known up to this point, guess what I have to do? What I knew was the maximum was not the maximum. It's time to update it. So that's what the then statement is doing here. It's basically saying, okay, whatever I thought was the maximum is not the maximum. Let's go ahead and update it because I just found a particular element that is greater than the maximum that I have known up to this point. So that's the basic idea of the algorithm, and it works. It works on any type of array, but this is more intended for arrays that are not sorted than arrays that are sorted. So here's the last question. What is n doing here? N is representing the number of elements in the array. There's no easy way to get to the number of elements in an array other than explicitly storing it or representing it. Now that is a big deviation from what some of you may have learned in your previous class, because some of you, especially those who took P300 from me, would use the bar A bar notation to represent the number of elements in A. That does not work in actual C, C++ programming. Okay. All right. Are there any questions about this code here? Questions? How about we turn this into an actual program and just run it? Okay. So we'll write a simple program to read a certain number of integers into an array of integers, and then we'll run this code to find the maximum and print it out. Okay. So let's go ahead and write that program. And when we are writing this program, I'm also going to go through the process of writing a program involving arrays, so that you guys can kind of use that as an idea when it's time for you to write your own algorithm, write your own program using arrays in C, C++, you can kind of borrow the approach. Okay? So we'll go ahead and write a program called findMax again, findmax .cpp. All right. So the first thing we want to do is to say, well, although I can put everything into main.cpp, the main function, I'm not going to do that. Okay. Instead, what I'll do is I'll have two subroutines. One subroutine to read all the integers into an array of integers, and then the other one to find the maximum. Okay. So I'm trying my best to kind of separate the logic in the program into smaller chunks. It is called modular programming. In other words, I am talking about modular programming, top-down design, except I'm not just talking about it. I'm going to illustrate it with actual programs. Right? So we'll start with main first. okay? Because everything starts with main, and this is called the top-down design approach. The top-down design approach says that's main, and I'm going to declare and allocate an array. Let's just call it A. Okay, so A is an array of integers, and then whatever you specify inside the square brackets, specify the number of elements in this particular array. I'm tempted to just say 32 or 5 or whatever number I want to use here, but that is not a good approach. Because if you want to change the number of elements of this array, it's kind of tedious to have to keep track of that constant number. So what I would do instead, using C and C++, is to use a const int, okay, and we can just say number of elements, initialize that to the actual value that I want. When you look at num element as a variable, quote unquote variable, now I said quote unquote, why do you think I emphasized on quote unquote? Because of the keyword const, okay? And the keyword const, what do you think it does to a variable? It turns it into a constant, okay? In other words, I'm not really just initializing num element to an initial value of 5. I'm saying that it has a value of 5 and it cannot change, ever. So this really is not a variable anymore by how we are going to use it. It is more like a constant at this point. But in terms of C constructs, num element is still called a variable, okay, even though we cannot change it anymore. So now that we have this initialized to 5, we can now refer to num element when we want to declare an array of 5 elements. Do we have any questions about line 3 and 4? Whenever you stick a const before the declaration of something, it means that cannot change, or at least not supposed to.
But you can go in and change it if you want to.
If you change it, the compiler will complain and say that you're not supposed to, and it will give you not a warning but an error. The program would not even compile. Okay, and we'll put a return 0 here. Okay, so I'm just going to do this part and compile the program. And unlike in previous classes where I just exit the editor and do it, what I'll do today is I'm going to open a new tab here, so this way I can just kind of do the compiling on this side. Okay. So -g -c -wall find max. I may not have saved it. There we go. .cpp, unused variable, but otherwise it's okay. Okay, it doesn't complain about anything else. Of course it's unused. Do you see that I use array A for anything here? Nope. I made a declaration. I said, hey, compiler, give me an array and call it A. But I did not use it for anything. Well, that's okay. I mean, that's just a warning. Okay, so let me answer that question. Can we change num element in the rest of this code? And if I do, what's going to happen? So we'll say num element is now changed to say 7. Okay, save the code, go back to my compiling screen, recompile the program, and now we have an error. It is not a warning; it's an error, which means that it will not give me an object file to link with later on. So when we look at the error message, which is right here. It says error, assignment of read-only variable num element, and it even identifies which operator is changing it. Are there any questions? I think that kind of really helped illustrate what a const is really about. You cannot change it. Okay. Yes?
So the array cannot grow or shrink then?
Nope. In C, C++, an array cannot shrink, it cannot grow, it has to stay. Once you allocate 5 elements, it will always only have 5 elements. It is completely static after it is declared. Okay. Right. So far, so good. Any other questions about this program? Yep, go ahead.
So when we put num element with 5, that means the array has 6 parts to it?
No, it means it has 5 elements. The indexes will go from 0 to 4. Yep. That's why the index of the last element is the number of elements minus 1. That's one thing that most people forget is we are counting from 0, and as a result, the index of the last element is the number of elements minus 1. Okay. All right. Any other questions about this particular code at this point? Okay. If there are no questions about this, then we'll go ahead and finish the main program, and then we'll deal with the rest. Okay. So the first part we want to do is to read in the number of elements that we want to read into this array here. And I'm going to do it in a subroutine. Okay, so we'll say, if read scan array. I'll use the word scan because I'm going to use scanf here. So if scan array, and then since it's a subroutine, you have to tell it where are we going to scan the array into. So you have to specify an array. In this case, we want to read everything into array A. And unlike most other programming languages, we also have to specify how many elements are there in A, which is really odd because isn't that a part of the array? Isn't the size of the array a part of the property of an array, and we should not really have to pass it separately as a different number or as a different parameter? You would think so, and that is the case in most programming languages, including PHP, Perl, Java, and many other programming languages. But in C, you have to pass the size of the array separately, okay? Because otherwise, the array does not know, the subroutine does not know where is the end of the array. Yep?
Is that why you use a constant for all of the arrays?
Yes, because now I can just say num element, right? Because num element is the size of the array. So I can now say scan everything into array A, and by the way, array A has num element, which is 5 elements. So I will say if this is going to return num element, I'm assuming scan array returns the number of elements actually scanned, then we'll go ahead and do the rest. Okay? The rest is simply to print f, and I'll say %d is the maximum line feed, and we'll print directly from find max array. So same thing, this is a subroutine that I'm going to write, and I will give it array A and also indicate the number of elements in the array. And that's my main program, that's my main subroutine. Okay. Are there any questions about the main subroutine? Other than, hey, I don't know of any scan array or find max array subroutines. This is top-down design right here, okay? I'm describing overall speaking what the program is supposed to do without worrying about the details first. Okay? All I'm saying is I'm assuming there's a function called scan array. It will use scanf to read elements into array A, and it will return the number of elements that it actually could read. And I'm also assuming there's another function called find max array, which will find the largest maximum value of an array if you give it the array and also number of elements in the array. That is top-down design. I'm not too worried about the actual details of scan array at this time. Okay, does it have to deal with error handling? Does it have to deal with error recovery? Don't know. What base of numbers is it going to use? Hexadecimal or decimal? Don't know. Okay, not worrying at this point. Are we doing okay so far? Yes, go ahead.
So whenever we do with arrays, we have to specify the name of the element?
Not so much. You have to look at the actual function first. Okay, but so the answer is yes and no. Okay, when you pass an array as a parameter, you always have to indicate which array are we talking about and how many elements are in that array. So that's why you have to pass 2 parameters whenever you pass an array as a parameter to something else. Because there's no other way to find out how many elements we have in an array. That's the biggest problem of C and C++ programming, which has to do with the low-level programming nature of C and C++. We'll talk about this later because arrays and pointers are very much related. In fact, in many cases, they can be considered the same thing. Any other questions? All All right, if there are no other questions, I'm going to write the other two subroutines, okay, and then we'll be done. So I'm just being lazy here, and I'll just say int scan array, give it a body of something, int find max array. All right, which will not compile, okay, because we have to specify the types of the parameters of each subroutine that we are writing. And we have to make sure that the parameter on line 1 will agree to how we use scan array on line 14. Okay? So we need to give it how many parameters? We need to give it exactly 2 parameters. What is the type of the first parameter? What is A? A is an integer of array, exactly. So how do we specify a parameter is an array of integers? This is how we do it. Well, this is one way to do it. I'm trying not to cause any confusion at this time, so I'm going to use this particular notation. It is saying that A is an array of integers. Does it say how many elements are in the array A? Nope, does not say that. Okay, there's no way you can actually specify that here. If you stick num elements here, the compiler would not recognize it. It would just say, don't know what you're talking about. All right? This is a big limitation. Well, on one hand, it's a limitation. On the other hand, it is because of the low-level nature of C++ as a programming language. The second thing is, what is it? The second thing is num element. What is the type of num element? It's just an integer, okay? So we'll just say int n, okay? I just call it differently as a parameter. Okay? In fact, A doesn't have to be A. We can just say array, okay? Array is not a reserved word in C and C++, so you can use that as a variable name. Okay. Are there any questions about this code so far? Are there any questions about line 1, how it relates to line 14? The list of parameters and the return value of this subroutine has to match how we use it. Is that okay so far? Any questions?
So that 5 over there, we can put any number over there, anything over there, and that program will give me the maximum.
So, could you ask that question again?
Okay. I mean, so that's at 5 over there. So if I put like a 3,000 over there, so when I just enter the number, so it will give me the highest number, the maximum number?
Well, that's the idea. The program is still being constructed, but I want the program to behave like the way you describe it. Okay. If there are no questions about scan array, I'm going to move on to find max array. And you can see the parameters of these two functions are identical. Okay, see how these two are identical? So I can basically use the same way of passing the arrays here. So I'll just say y, and go to the next match of parentheses, and do a paste. Paste. There we go. So I just did a copy and paste in C++. In VI. Okay. All right, so we'll just kind of consider the program like this so far. Am I done? I'm far from being done, because at this point I have just created the shell of the subroutines, right? Fine, I'll give it something. How's that? And that obviously is not the right answer, okay? It's something there. It does return a known value. One will return n, and the other one will return 0. Why would I do something like that? See if it compiles and see if it runs, right? Because in this case, it should run, and it should come back and say 0 is the maximum. That's the expected behavior. Right, we need a few things after this. We need to pound include stdio.h, because otherwise I cannot use a printf. Okay, and later on we have to use scanf as well, so we need to use that. Save the program, and we'll go ahead and try to compile. without any problems. We'll go ahead and link the program. And run the program, and it just says 0 is the maximum. This is a part of top-down design. Okay, I'm designing the program or writing the code from the top down, which means I will have to create what we call stubs. Okay, if I go back to the editor, the way I write scan array and find max array does not contain the actual logic, and that's why these are called stubs. They will make the compiler happy, the compiler will compile, and the program does run in a predictable way, but otherwise the functions do not implement what they're supposed to do. Is that okay so far? So the next thing we want to do now is to implement scan array. You can make it fancy and scan for look for errors and recover from errors. I'm just going to stop as soon as I see something that is not a number. Okay. So I'm just going to make this short, because the point in this particular exercise is not to illustrate how to use scanf to detect and recover from errors, but to utilize arrays. So I just want to focus on that part and not so much the other part which we have already talked about. So in this case, I have a new variable I, and do you guys prefer me to use for or while? Because they're pretty much the same thing. While. We need a vote now. Okay, how many people are while? Okay, and how many people want me to use for? Okay, I think the whiles have it. The while version is actually the more quote-unquote universal version, because while is in every single programming language. For, at least the way C++ uses for, is not quite universal. Okay, so I'll use the while way. This is the initialization, so you can convert it yourself too if you want to. So this is the initialization, and this is the condition. Condition is this. Well, at least at this point it is. And then the post operation is this. I can just use ++ I here, just saving a little bit of typing here. So for those of you who prefer a for loop, change it. Okay, I equals 0 is the first part, comma, and then I is less than n is the condition, the second part. Excuse me, semicolon. Okay, so it's I equal to 0, semicolon, I is less than n, semicolon, and then ++ I is the post operation, and that will be the last part of the for line. Okay, so it really is just a syntactical difference between using a for loop as opposed to a while loop. The most important part is, what are we doing in this loop? Okay, well, ideally speaking, this is all that we are doing. We are going to use scanf to read an assigned integer, and that's why I'm using %d and not %u. And we are reading it into where? There is the question. What do I put here? Well, we're supposed to read into the array, right? But I cannot read into the entire array, because the entire array is not an integer. What is an integer? An element of the array is an integer. So tell me again, how do I get to an element of an array? We use the indexing operator, which is the square bracket. Okay, so we can now say a bracket I. Okay, that gets me to a certain element, but that's not right either, because when you are dealing with scanf, it wants to read into a place. Okay, a bracket I refers to the value, the content of an element of an array. What do we need instead when we are dealing with scanf? The address of. Okay, and which operator is going to do that? Ampersand, exactly. In this case, we do not actually need parentheses, because ampersand is going to be applied last. But if you want clarity, you can always add additional parentheses to emphasize that we are taking the address of not A, we're taking the address of an element of A, using I as the index. Okay. And clearly, we also need a semicolon here. Yep.
Didn't we name it array, not A, inside of this subroutine at the top?
Oh, you're right. I named it as array. Thank you. Good. Okay, that's all we are going to do in this particular loop. Okay. Are there any questions? I have a question, Tack. You mentioned that I would stop reading as soon as we encounter an error. What if the numbers that is given to scan array is not all numbers? What if I have some symbols or lowercase, uppercase characters in it? Well, it will still be okay because it will attempt to read into those, but it will not be able to proceed, right? Because it would be stuck with whatever is not a number. It would be stuck. So even though it will keep attempting to read into the other elements in A, it would basically fail with all the future attempts. But I would not be able to tell how many it has actually read successfully. So to make this code do what I claim that it should be doing, I have to make it a little bit better. So I'm going to say scanf result here. Okay, this is just another variable. And there are several ways to do it. I can do it with a pre-checking loop like the while loop, or I can do it as a post-checking loop, which is do while. In this particular case, I can do it like this. I can say scanf result is assumed to be a 1 so that I cannot fail that condition in the first attempt. So I can say if as long as I is less than n and scanf result is a 1, I'll keep doing this. Except every time I perform a scanf, I will also store scanf result like that. Are we doing okay so far with this code? I'm using scanf result as a variable to remember whether the previous scanf was successful or not. And the first initialization, or the initialization on line 8, has to be there because otherwise the condition on line 9 will be comparing to something that is uninitialized, which is not okay. Are we still okay with this code so far? So I'm just attaching a little bit more code each time. Okay. So this will give the loop an ability to exit early if I have some junk in the input, or I encounter end of file ahead of time, way before I can get the entire array read. But when I return, I don't want to return n anymore. I want to return I, because I is now indicating how many things was I able to read successfully. It could be 0. Okay, if I just give it ASDF and then that's the entire file, this will return 0, which indicates I did not read anything at all. Okay. Are we still doing okay so far with scan array? Are there any questions about how I utilize array as a parameter on line 11 in scan array? Questions? Okay. So you can see how we are now combining something that we just learned, which is array indexing, with something that we have learned already, which is the address of. Those two concepts are completely orthogonal, which means they are not, one does not really impact the other one, and that's why they can stack up. That's why we can apply one on top of the other one. Okay. All right. Well, if this one is working, let's test it, right? We've got to test this code. But to test this code, it might be better to give it an else in the main program and just say printf. I probably want to return some number which is less than the number of elements that I'm expecting. Is read cannot use find x. Okay. All right, so this is the format string. The format string is expecting 2 integers. The first integer is going to be the actual number of elements that we have read, and then the second integer is the number of elements that I'm supposed to read. Are we doing okay so far with the intent of the printf? Because this is an error message, okay? I did not read the number of elements that I'm supposed to read. I want to return an error message that basically says the number of elements that I was able to read is less than what I'm expected to read. Is that okay so far? Are there any questions about the intention of line 33? No questions? Okay. The second number is the easy one. Okay, the second number is simply num element. Okay, that's how many elements we're supposed to read. What about the actual number that we have read? We know that we once had that result because when we call scan array, it returns the number of elements that I was able to read. Unfortunately, I did not store that anywhere, so we cannot use it. So we have to now store the return value of scan array someplace. So let's go ahead and store it, into a variable. We'll just call that number of elements read. And this one does not need to be initialized because we are going to get it here. So now we can now say num elements read equals to scan array, and use an extra pair of parentheses in this case. Are there any questions about line 29? This is a typical C++ programming style, which is not necessarily a good one, is to utilize an assignment operator in the middle of a comparison operator. So when you look at how the parentheses are nested, you can see that it is quite clear that we have to deal with the assignment operation first. So the first thing we have to do is the right-hand side of the assignment operator, which is the function call that will actually go ahead and try to read values into elements of an array. That's the first thing we do. What do we do with the return value of scan array? It's the assignment operator, right? So the first thing we do is to store that into the variable called num elements read. It really is an assignment operator. It is intended as such. It is not a typo, okay? Because in some cases it's just a typo because we intended to compare. This one is intended as an assignment operation. As an assignment operator, in addition to changing the left-hand side of the operator, is there anything else an assignment expression should do? It will also give a value. Every expression has a value. The assignment operator, which is an expression, also has a value. What is the value of an assignment operator?
1.
No.
The left-hand side.
Whatever the left-hand side ends up with, right? Or whatever the right-hand side is, okay? So in this case, the right-hand side is the scan array, which is the number of elements that we actually read. So the comparison is actually just comparing to the right-hand side of the assignment operation, which is also what I want to do. So I'm combining an assignment operation and a comparison onto the same line on line 28. As I said, it's not particularly a good programming style, but you need to understand it because you will see programs like that written in this particular way, not only in C and C++, but you also in PHP and Perl and many other languages that are derived from C and C++. So this is one thing that you definitely need to understand, even though you may not agree that this is the best way to do some programming. Okay. All right. So now that we have this num elements read actually having a value, we'll just go ahead and use it here. Num elements read is the first thing to fill in the first %d. So now if I did not read exactly 5 elements, I will end up with the error message, which tells me the number of elements that is actually read, which is less than what I'm expected to do. All right, let's go ahead and test the program. Compile, whoops, compile is this one. And then we link, and then we run the program, and I'll just give it 1, 2, 3, 4, 5, 6, 3 integers, and then some gibberish. Okay. Now before I press the enter key, I really should think about this and say, I think this program should do the following. Okay. I think the program should say 3 is less than 5 elements is actually read. It will give me the error message and not the first one. Okay. Let's see whether it does that or not. It says 4 out of 5, not 3 out of 5. Why do you think it says 4 out of 5 and not 3 out of 5? It has to do with...
This still adds 1 to I.
Yep, because the +1 to I is unconditional. When you go back to this code here, see this ++I? It is always going to execute after line 11. In other words, even if line 11 returns something other than 1, as scanf result, I'm still going to increase I by 1. And therefore, we are counting it 1 more than what it should be. Okay? How do we fix this? How do we fix this? So, sorry?
Before the scan.
Say again?
You put it before the scan.
If I do the +1 before the scanf, it will affect where I'm reading it into, so I can't do that either.
Say if scanf result equals 1.
Exactly. I need to compare first. So I have 2 ways to do it. I can do it in the questionable programming style, which is combining the comparison and the assignment into one single line, or I can do it in a slightly more readable way, which is do this first and then have the comparison, or I can use a ternary operator. Let's do it in a ternary operator, just so that we can reuse things that we are supposed to have learned. Note the way I said it. Things that we're supposed to have learned. Which is not necessarily something that everybody remembers, and that's why I'm doing it again, just so to refresh your memory. This is how we do it. So we can say, I is scanf result. Compare that to 1, which is what we want. If it is 1, that's good. Okay, we'll just go ahead and increase it by 1, which is plus equal 1. Otherwise, don't change it. In other words, I'm just adding 0 to I. Are we doing okay so far with line 12, which is a conditional statement, except it is expressed as an expression? Is that okay? The right-hand side simply says, if we did exactly read one thing, go ahead and increase I by 1. If not, increase it by 0, which means don't change it. Okay. All right, with that change, we are expecting the program to behave a little bit better this time, so we'll go ahead and recompile, relink, rerun the program, and I'll give you the same input, which is 1, 2, 3, 4, 5, 6, ASDF, press the enter key. This time it does come back with 3 is less than 5 is red, cannot use find max. Now I know this is really terse, I should have said 3 elements was red, 5 was expected, and so on and so forth, but since we kind of know the context of this, I'm just going to leave it like that. Okay. Are there any questions about this program? Are there any questions about the use of arrays or the use of scanf? In other words, I think when you look at this sample program, it is not really just to illustrate the concept of using arrays, but it's also a review of scanf. It's also a review of using ternary operator, and also in a way, I'm trying my best to show you how to write a program. Did I write a scan array just from line 3 all the way up to line 15 in one single stroke? Nope, I wrote it in steps, right? And then between the steps, what did I do? I tested it. Okay, I test the code. Okay, this is confirmation, it's working. Okay, move on to the next step. This is not what it's supposed to do. Let's fix it first. Okay, and how many lines did I add every single time between the testing sessions? Just order of magnitude. 5, 10 lines or so. Okay, what do you think will happen if people try to write a 400-line program without any testing? And then after writing all 400 lines, what do you think will be the first thing to happen to that program? It'll run perfectly. Okay. Well, I have yet to do something like that myself. Okay. So it's possible that many of you are better programmers than I've ever been. But to me, that has never happened. What is more likely to happen?
Errors.
What kind of errors? Compiler errors, right? The compiler will start screaming because of just simple syntax mistakes, right? I made a few. Okay, I forgot to use array as the name. I use A. Okay, so the compiler will catch that one and complain, going, "Hey, I don't know what A is." I might have forgotten the semicolon. Okay, at the end of one expression statement, if I forget a semicolon, the compiler will complain and go like, "Hey, this is not a statement." If I miss a curly brace, which I have never done because of the way I type a program, it will have massive problems with that. Okay, so and that's why we don't want to write a 400-line program in one single stroke. Okay, it's not going to happen. It's just going to be a lot of frustration. Okay, if I do it this way, I get feedback along the way, so I can kind of build up my confidence also. Okay, okay, I got this part of the program done. Good. Let's move on to the next step. And when you move on to the next step, you kind of have the confidence that at least the program has been working up to a certain point. Okay, let's move on to the next one. Find max array. So let's actually go ahead and do it. We'll go ahead and just kind of plug in the code from before. Okay, so I'm going to say max is array bracket 0, the first element, and I is 1. I know I have not declared the local variable. I'm just kind of reciting the algorithm from the other window first. So while I is less than n, in this case, we'll do the following. If a bracket I, or array, forgetting that, if array bracket I is greater than max, I have just found something that is greater than max, which means maximum or max needs to be updated to the new value that is greater. And then at the end, I have to increment I. When this is all done, I will return max, which is the maximum of the entire array. So this is the general idea. Okay, basically, I'm just plugging in the code that I wrote a little bit earlier into this subroutine. And the only part that I have not done at this point is to specify, oh, what is max and what is I? Max is not a parameter, okay, so I need it to be a local variable. I is not a parameter either, it needs to be a local variable. So I just need to declare max and I as local variables, and I think the rest should be okay. Are we doing okay so far with find max array? Before we go compile the program, let's take a look at the entire, well, not quite the entire program, but 2 lines in particular. Let's take a look at line 11 and line 25. Okay, those 2 lines are specifically important in the context of today's class. It has to do with the use of I as an expression inside a square bracket. Okay? When you look at those 2 lines, line 11 and line 25, this is the first time that we have seen a particular expression that will change what it is actually using for assignment or comparison, or as a parameter, depending on the value of an expression. In other words, when you look at line 11, let's just focus on one. Let's focus on line 25 because it's the one that we have seen lately. So let's look at line 25. Line 25 is magical in some way because compared to what we could do before, is in the first iteration, it will be comparing array bracket 1 to max. That's in the first iteration. In the second iteration, it will be comparing a array bracket 2, then it will be comparing a bracket 3, and then array bracket 4. But it's the same statement. It's possible to address a different element only because inside the square bracket is an expression. And that expression can be a constant, okay, like on line 21, I'm using 0 as a constant. So that is not particularly exciting. Look at this one here. That's not particularly exciting. In other words, on line 21, it's always going to refer to the first element of the array and say, oh, initialize, take this value and use it to initialize max. Not very exciting. But when you look at line 25, it is quite exciting because of the way I update I per iteration. Every time I execute line 25, it is now going to compare a different element of the array to the quantity of maximum. That is the reason why arrays are so powerful, because it gives you a way to use the same expression, but depending on how other variables are changed, that one single expression can refer to a different element of the same array. Right? Is that okay? Does everybody understand why arrays are so useful? So conceptually speaking, this is why arrays are so useful. Structures cannot do the same thing, because with structures, to address a particular member of the structure is a name. It is static. This can be any expression. In other words, if you have the need, this expression inside a square bracket can be very complex. As long as it returns an integer that is between 0 and the number of elements in the array minus 1, it's okay. So it can be an expression only this long, which is I, can be very complex. It doesn't matter, okay? All right, so now that we have this program, I think pretty much written completely, we'll go ahead and recompile, relink, and then rerun the program. And this time we will give it 5 different values just to see if findmax itself is working or not. So we'll give it like 6, 10, 2, 0, and 67. And it says 67 is the maximum. Can someone tell me what would be quote-unquote boundary cases for this particular program? How should I test it?
For more than 5 numbers.
Well, if I give it more than 5 numbers, it will still read only the first 5. Okay, so let's try that. 1, 2, 3, whoops. Run the first. 1, 2, 3, 4, 5, 6. And returns 5 is the maximum because it's ignoring everything after 5. Okay, that's good. The boundary cases, as it turns out, will be the first element and the last element. In other words, I want to make the first one being the maximum, make sure it works, make the last one the maximum, and also make sure that works. Because if you have any initialization issues and forget to initialize the first one, or initialize it incorrectly, or terminate the loop incorrectly, then the first or the last one will show up. Okay, well, the incorrect maximum will show up when it is the first or the last. So I have already tested the last one, which is this test case. I just need to test the first one. So at 67, 1, 2, 3, 4, and return 67 is the maximum. So it is working for the 2 boundary cases that I have identified. Okay. Are there any other questions about this code? Yep.
Do you have to use spaces or do one number at a time? Like how you did it there? Or just do one number?
Enter is the same thing. So C and C++, when it's reading a number, it has a whole bunch of characters that it thinks are what we call whitespace characters. So whitespace characters are basically ignored. It will not report an error. So in other words, in your homework assignment, if you say 34 space, slash 56, I think it will still accept that one, okay? Because an empty space is, can be ignored. So in this case, I can have 2 spaces between the numbers and it will still work the same way. So if I have A spaces, 5, and then here I can use a tab character, consider the same thing. And then the enter key is the same thing. Line feed and carriage return is also considered white spaces, and they're ignored. So they won't give you any errors, and that's why the error checking part is not kicking in and say, hey, this is not a number, it's time to exit. So I can now give it like 6. Negative number should work as well, but it's not going to show up because it's not the maximum. And I can press the vertical tab character and line feed characters are also considered as white spaces. Line feed, page feed character, which is I think Control L, is also considered a white space character. So I can give it one last number, 10, and it says 10 is the maximum. So you can give it a variety of what we consider white space characters, and it will just ignore those. Are there any questions about this program at this point? No questions. Let me go back to the program, and I'll give you a question. And the question is, what if I make a mistake and turn that into a less than or equal to? That doesn't seem to be a very major mistake, right? But what we would do?
Would that be an error because it's going to try accessing a number or a spot in the array that doesn't exist?
Exactly. It is going to try to access an element that is not a part of the array. Hold on a second here. How is that happening? Well, if I is less than or equal to n is the condition to stay in the loop, in the last iteration, I will be n, right? So if you just plug in the equivalence, I is actually n onto line 25, then we'll be accessing array bracket n, and we'll be comparing that to max. And what exactly is that? How big is the array, by the way? How many elements do we have? 5 elements. And so we'll be trying to address array bracket 5 in this case, right? That seems okay. 5 elements, index being 5. What is wrong about this?
Starts with 0.
We start counting from 0. So that means when the array index is 5, it is no longer an element of this array. What is going to happen? Okay, so that part depends on which programming language you're dealing with. In Visual Basic, if you try to access an element that is not a part of an array, it will give you a runtime error right away. It will complain about online blah 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 blah. Okay, you are trying to access an array out of bounds or something to that effect. You will know about it. It's going to stop executing right there. It will just tell you we have a problem. In Perl and PHP and most scripting languages, it will make the array bigger so that the element that you want to access starts to exist with a default value of 0. Okay, so that means if an entire array has negative values, it will make a new element exist with a value of 0, and that 0 will become the maximum, which is wrong. But the funnest part, the programming language that will give you a great deal of fun and challenge and enjoyment is C and C++, where it will just access where that element is supposed to be and say, you want element number 5, which is the 6th element? Sure, I think if it did exist, it would have been here. Let me give you that to compare. That is what C and C++ will do. So in this particular case, you might end up with a value as a maximum that is not a part of the array, okay? Which is wrong. But if that is the case, you're lucky because you can spot it almost right away and has no long-lasting side effects. Let's think about the other loop. Okay, so we'll fix this one first, okay, and go to the other loop and say, what if I make a mistake here instead? What is the difference between find_x array and scanf array or scan array? Just in terms of what we are doing to the array.
This one we're writing.
This one will overwrite, right? Okay. So if you try to use less than or equal to on line 9 instead of less than, then in the last iteration, I would equal to n by the time we get to line 11, which means we're going to ask scanf and say, give me an integer, I will store that to array bracket 5, which is an element that does not exist, right? Because the array only has 5 elements. But what would happen instead is it will look at the memory, whatever it is, that is right after the last element of the array and say, if element 5 does exist, it would have been here. Let me overwrite this location as if it is element 5. Hold on a second here. That is not really a part of the array, which means it's not allocated for the array. What do you think those bytes are allocated for? Exactly, it could be for anything. In other words, it could be allocated for another variable. So when you try to read into that location, some variable that has nothing to do with the array may be modified. And consider yourself lucky if that is the case. Okay, because in the memory of a computer, when the program is in execution, there are things in memory that are stored, but they do not correspond to actual variables that are named. And yet, if you change those things, it can alter the behavior of your program in mysterious ways until you take cisp360, which is a shameless plug of the next class or another class that you can take after this one. So that means for any even experienced C and C++ programmers, if they do not understand assembly language programming or how memory is actually utilized when the program is in execution, a problem like this one, okay, on line 9, can end up with a symptom that cannot be debugged because the behavior of the program cannot be explained, and it has to do with the corruption of memory locations that do not correspond to named variables it is corresponding to other type of bookkeeping information that the compiled C program needs to maintain. And changing those locations can make the program behave in really, really nasty ways. Okay, crashing is the easiest. It's the best thing ever. Okay, if the program crashes right away, then you are pretty close to the source of the problem, and it's okay. But many times it's not going to crash right away, depending on what you do with these locations. A lot of times you can change one thing that is incorrectly all the way here. The program will execute thousands and thousands of lines until the symptom actually shows up. By the time the symptom shows up, it will be really hard to associate that symptom with something that happened way earlier. Okay? I cannot really quite explain that in this class because we are not going to write any programs that are really complicated, but I can just give you, that assessment and say, that's the importance of cisp 310. It will give you the ability to debug C, C++ programs that are written incorrectly, which some programs will be anyway, but it will give you the ability to kind of x-ray into the program and find out, oh, so this is what I did that was wrong. At least we'll start with certain correct suspicion. Okay? Otherwise, you'll be looking at a program and the symptom of the program go like, I have no idea why this program is doing it this way. Okay? Are there any questions about that? I know some of you do not have to take cisp 310, so this is going to be the last class that you have to take in this series. But for those of you who have to take cisp 310, which is assembly language programming, and to many people, why do we need to learn how to program in assembly? Because that's such a low-level type of programming. Nobody would actually write programs in assembly language. That's not the point. The point is to make you a better C, C++ programmer. That really is the point of cisp 310. All right, so we are running out of time of the lecture. I forgot to pass the roll sheet today. Again, they have to make make me teach classes that are less exciting. So I would actually try to find things to do other than teaching the material. Then I'll remember to take roll. It's like, oh yeah, take roll. I got nothing else to do now. But with this class, we will run out of time before we run out of topics. Okay. Are there any questions? I don't have any real structured lab today. So if you are going to do your homework assignment or I have questions about that, I'll be here to answer those questions. Otherwise, I'll see you on Wednesday.